Okay, so hello everyone. The question which we will be solving today is number of ways to arrive at destination. Okay, so this is today's LeetCode POTD. Okay, and as you can see, the question number is 1976 and it is marked as a medium, right? So, okay, so let's just read the description and try to solve this problem. Okay, so you are given, you are in a city that consists of n intersections, okay, numbered from 0 to n minus 1, with bi-directional roads between some intersections. Okay, the inputs are generated such that you can reach any intersection from any other intersection, and there is at most one road between any two intersections. Okay, so I will like be explaining it to you. Okay, let me just first read the whole description. Okay. You are given an integer n and in 2D integer array roads where u of I, v of I, and time I. Okay, means that there is a road between u and I, u and u and v of I with the time of y. Right? Okay, there is a road between. Let me just write it. So there it is. See, what does this means? That there is a road between ui to vi, and to travel from like and to travel from one point to another, like from ui to vi, the time taken is the time is equal to t of I. Okay, which is given in the question, right? Okay. You want to know in how many ways you can travel from 0 to intersection n minus 1 in the shortest amount of time. Okay. Return the number of ways you can arrive at your destination in the shortest amount of time. Okay. Since the answer may be large, you return it modulo 10 raised to power 9 plus 7. Okay. Like in terms of code, you can write it something like this. This can be written at 1e9 plus 7. This is the way to. So now let me just go through the question once again. Okay. You are given a bidirectional roads between some inputs are such that you can reach any intersection from any other intersection, and this at most one road between any two intersections. Okay, so what does this mean? That see, like you can see that it's a graph, right? So the graph is connected. How can we find it? Like how can we figure it out? Because there will be at most one route, and you can reach from any point to any point, right? Okay. There won't be a case like this where you can't reach. Okay, so that won't be a case. So what we need to do is that return the number of ways you can reach in shortest amount of time from intersection 0 to n minus 1. Right? We need to return the number of ways from which, like number of ways in which we can reach from point 0 to point n minus 1 in shortest amount of time. So let's just start building it by the sketch. What do we need to find? Shortest amount of time. Right? Okay. Shortest amount of time, which means the like what we can say a minimum distance. Okay. So does this remind of something like the shortest amount of time or something like that? Okay. So can we use something which we have studied? Yeah. Dijkstra will help us to find the shortest amount of time to reach that point, right? Dijkstra can do it. Right? Okay. And see, like how will we how we will be finding the number of days? This is the like I would say the main point because we can like easily find the shortest time, right? Okay. So now the main focus is to find the number of days, and we are using the Dijkstra. Okay, so let's just do some observations. So suppose there is a point A. Okay, should I write it? Let me write it. Suppose there is a point A. There is a point. Let's suppose set. There is a point B. There is a point C. There is a point D. From A, you can go to D. Okay. From A, you can go to B. Okay. From A, you can go to C. And let's suppose there is a point F. And from D, you can go F. And from F, and from C, you can also go F. And from like B, you can go to Z. And from C, you can go to Z. And from F, you can go to C. Okay. So in this question, we need to find the number of ways. Find the number of ways in which we can reach it. Find number of ways to reach it. Okay. So if we can go this way, okay, we can go like one, two. Okay, okay. So let's just break it bit by bit, like the intersection by intersection. Tell me in how many ways you can reach B. One, right? From A to B, you can reach by is only one. Okay. Suppose we were standing here, and in how many ways we can reach A? Like, okay, so let's just leave it. We are focusing on. Tell me in how many ways you can reach C. One. Okay. Tell me in how many ways you can reach D. Tell me in how many ways you can reach F. Okay. Like suppose we are reaching it from D. Okay. So that will be a one way. Okay. And we are reaching it from C. So that will be another way. Okay. So we can reach it from two ways, right? Okay. So here it will come two, right? In two ways we can reach F. Okay. Now tell me in how many ways you can reach Z. Okay. One way is we go from A to B and B to Z. Okay. Another way is we can go A to C and C to Z. Okay. One way will be we can go A to D, D to F, and F to Z. Okay. And one way we can go A to C, C to F, and F to Z. That will be another way. So in four ways we can reach. Okay. So tell me one thing. What is this written? Is this the number of ways we can reach F? Right. Is this the number of ways we can reach C? And is this the number of ways we can reach B? So if you sum these, you can easily find the number of ways reaching Z. Which means, like, see, suppose standing here, like, where did you come from? You can come from B, you can come from C, and you can come from F. So if you sum the number of ways you can reach these points, you can get the number of ways reaching the Z, right? Okay. Same things goes for the F also. If you can sum up the number of ways reaching, like you can reach F from C and D. So in how many ways you can reach point C, which is 1, and in how many ways you can reach point D, which is also 1. Okay, so if you sum up, this will become 2. Right. Okay. Okay. So this is what I am trying to say. Okay. So let I just okay. So now let's just if we can like modify this example also. Okay. If we want to like take a more better understanding of it, let me just do it. Take another example, or we can just uh, take the given example. Will be okay. See. Just, okay. So can we combine these two concepts? Okay. I think we can. I think we can. See. From 0 to 6, the cost is 7, right? 7. From 0 to 4 and 4 to 6, the cost is this and this. This is also 7, right? From 0 to 1, 1 to 3, and 3 to 6, the cost is 7. Okay. And from like this, we can go 0 to 1, 1 to 3, 3 to 5, then again 5 to 6. You can get the cost of 7. So there are 4 ways. But if you like remember the Dijkstra code, it's like something like this: the cost plus current cost must be less than the result of the point. Okay, so this is the condition, like the relaxing condition. Okay, this is the condition. Okay. So what do we do in this case? Like this is the if. Okay, we write an else if the cost plus current cost is equal to the result of V. Then what we can do? We can just add the number of ways, right? See, uh, Okay, so this is how we are going to solve it, right? We are combining the Dijkstra plus the finding the number of ways, right? Dijkstra plus finding the number of ways. See, in this example, it's not like that. Okay, it's not going like that. But I will be show. Let me just show you another example. Okay, in this, in which this part will be more clear because you know extra. This needs to be like located to it. Okay. So, okay. So if there's a point A, and let's suppose we go from A to B, and we have B to C. Okay. We can go directly to C also. We can go from D and then D to C, and there's an F, and from F we can go to C, and let's say from C we can go to Z. Oh, okay. So I think this is a good example. Right? Tell me in how many ways you can reach A, 0, because we are starting from Z. Right. Start point. This A is a start point. Okay. Tell me in how many ways you can reach B. 1. Okay. Tell me in how many ways you can reach D, which is also 1. Okay. Tell me in how many ways you can reach F. 1. Okay. And so now tell me in how many ways you can reach C. Okay. We can reach from A, we can reach from B, right? We can reach from F, and we can reach from D. Okay. So in total number of 4 ways we can reach C. Okay. So in how many ways we can reach Z? The answer will be 4, because we can go from here, we can go from, so we can go from A to D, D to C, and C to Z. We can go from A to C and C to Z. We can go from A to B, B to C, and C to Z. In other case, we can go from A to B, B to F, F to C, and then to Z. Okay, so we will be checking neighbors, that in how many ways we can reach its neighbors, and then we will be going to sum it up. Okay, so this will be our like intuition. Okay, wait, should let okay, let me just add another some more notes to it. Then suppose we are going to reach, okay, we are going to reach G, and let's say there's a node T. Okay, so T is our target node which is connected to Z, G, and T, right? Okay, so this is our graph, this is our target. Target. Tell me how many ways we can reach. See, this we have covered. See, what was our answer? We can reach it here by in 4 ways. Okay, from there. So let me just write it down, because okay, this is a number of in one way we can reach. Okay, so if you now sum it, sum this, and this, then we will be getting the four. Okay. In how many ways we can reach Z? 4, right? Okay, so the graph is a bit complex now, right? Okay, because we have included like multiple dependencies. Okay. For now, in how many ways you can reach? Like 4. Okay. How many ways we can reach Z? 4. In how many ways we can reach T? We can reach from G. We can reach from Z and we can reach from F. So in how many ways? We can reach here in 4 plus 1, which is equal to 9. Okay. Now, you tell me in how many ways we can reach G. Okay. We can reach from here also. Okay. So it will become 4 plus 9. Okay. It will be 30. In how many ways you can reach plus 9? It will be 30. Okay. So see, I won't be going deep into this, but this is the how you can go. Okay. Let me take the example of G. Okay. I am trying to get to what we're trying to do it here. Okay, you can grow from 1 to D. See, this is the one way. Okay. Let me use a different color for it. Okay. See, this is a way, right? This is a way. 2, 3, 4, right? Now 5, 6, okay, 7, right? 8, 9, 10. Okay, so there will be more ways. Let me just find out. Okay. Okay, so we can go from here to here, then again to here, then we can go here also, then we can go here. So okay, so this is how we are calculating it. Okay, so we don't need to do the hardcore dry run of it, but this is the way of doing it. Okay, you might got the intuition of it. Okay, so let me just come up to the code and things will be much more clear to you. Okay, okay, see, starting from here. So we have, first we need to make adjacency list. Okay, here we are making it. Okay, it's bi-directional, right? Bi-directional. Okay, right? There will be one result and there will be count, right? Result will be initially 0 and the count will be 1, because there is in one way you can reach starting point, right? And then we are calling the BFS for it. Okay, so here is the BFS. Okay, we have used the priority queue. See, this is the basic Dijkstra code. Okay, it is like nothing is special in it. Okay, this is the basic Dijkstra code. We have just taken the priority. We have pushed the elements into it, and we are just doing the basic things. Okay, we have point the top, popped it. The weight will be first one, and the edge or vertex will be the second, L dot second. It will be at the L of second. We're iterating the adjacency of U. Okay, we're just finding the node, the cost, and we are storing the cost here. Just checking if true, we are resulting the result will be this, and we'll be pushing the current cost along with the node, and we are for the first time the number of ways you can reach will be the count of U, C for the first time, A, B, C, and D. Okay, so suppose taking the first time, for the first time, this will be 1, right? So for the first time, this will be 1. Then again, when we will be coming, we will be doing the count of U, right? See, because we need to, because at the minimum cost we are trying to do it. Okay, so okay, we can't just add it up. Okay, because here we haven't taken the, in the example we weren't taking the weight. Okay, but first the minimum cost matters, right? We don't need to blindly find out the number of ways. We need to find the minimum number of it, right? Okay, so are you getting the point? That's why we are just that's why here we are not doing this. We don't need to find the number of it. We need to find the minimum number of it. Okay, if it's equal to minimum, the result will be storing minimum, right? We know that. If it's equal to the minimum, then we will be finding the the adding this, right? Otherwise, we will just add initializing it with the count of view. Okay, set for the first time. For the first time, we are this will be two, okay, for the first time. But if some another see, suppose reaching cost from D comes to 10. Okay, so this will be 10 in the initial case. Okay, and how many number of ways? Two, right? Two. But suppose from here we go to E and we go to Z, and the cost comes like 3. So in this case, we won't be doing 2 plus 1. No, this will be if it's 1, then we will be considering it 1, not if here not the number of ways will be type 2, right? What I'm trying to say is that let me just see the number of ways is 2, cost is 10. Number of ways reaching here of ways is 1 and the cost is 3. So we will be considering this 3, not this 10, right? We will be considering this 3, not 10, right? This will be considered. So yeah, that's all for that's the what the main point was. Okay, and at the end we are just returning the count n minus 1. And as you can see, the code is running just fine. Okay, passing all the test cases. Okay, so yeah, that's all for this question and the solution, right? So yeah, the code link, the question link and the code link will be in the description box. Okay, you can visit out. Yeah, that's all for this question. Have a nice day. Okay?